Section B, question 7. So here we have a ballet company performs the Sleeping Beauty every year, and they gave total 60 performance last year, and then has a maximum capacity of the 800, right? That means they have ability to host about 800 people at a time per time, right? Then question AI, we need to find the value of the P. Okay, so P is located here. It's a number of the performance. And we know that total number of the performance is 60. So means when we add all these four numbers, they should add up to 60. So means question AI, to find the value of the P, we have to add 3 with the P and 18 and 30 and make it equal to 60, and after that we need to solve for P, which is same as 60 minus 3 minus 80 minus 30, then it gives us the value, P value of the 9. Then question AII, we need to write down the modal class. So modal class in a frequency table refers to a section or the class that has most frequency. So when you look at this right hand side of the table, you can see that the last row has the highest frequency of the 30. So it means the modal class is between 600 and 800. Okay, then let's go to question 7, number B. So question B involves with a cumulative frequency diagram. Means this question is based on this topic 4.2, cumulative frequency section. Okay. Then we can see that question BI, we need to find the median number of the tickets sold. Okay, that means we need to first find the middle number of the cumulative frequency. So you can see that we have highest number of the 60, right? So the graph goes all the way to 60. That means we have to do 60 divided by 2 to calculate the number that is located exactly at the middle. So we know that 30 is our middle number. Then we now have to figure out where this number meets the graph. So you can see that it meets the graph right at this point here. Then now we need to figure out where this point meets on the x-axis. So we go down. Then we can see that 600 is our number. So the median number of the tickets sold is 600. Then question BII, we need to find the number of the performance where at least 80% of the tickets were sold, right? Then we first have to figure out what number is the 80% of the tickets. Okay, so we know that from the previous question, we have a maximum capacity of the 800. That means we have abilities to sell about 800 tickets at a time, right? So we go 800 times 80% to calculate the 80% of the tickets. Okay, so we do 800 times 0.80, then we get about 640. So 640 is the 80% of the tickets. So we, on a frequency diagram, we first have to identify where the 640 is located. So it is located right here. So this is your 640. Then let's try to figure out where this value meets on the graph. Then we can see that it meets on the graph at this point here. Okay, that it will meet y-axis at 40. Then we can say uh, 40 is the number of the performance that is that where we can find the less than 80% of the tickets were sold. So that means we need to find the number between 60 and 40 to find the number of the performance where at least 80% of the tickets were sold, right? So we do 60 minus 40, which is equal to 20, and we can say this is the number of the performance where at least 80% of the tickets were sold. Okay, then let's continue question 7. And this time we have to do question C. So first question, we need to state one disadvantage of the company serving only the first 5% of the audience as they leave the theater. So this is a non-random sampling, right? And specifically, because we're just sampling the first 5% of the audience, this kind of ease of the data collection. We don't have to worry about how to collect the data. So this is definitely a convenience sampling. Convenience and sampling, and this is the disadvantage of this sampling method. Then CII, we need to describe briefly how the company could collect feedback from 5% of the audience using the systematic sampling method. And we know that systematic sampling method uses the interval. Okay? To have a systematic sampling method, we always have to use the interval to calculate or to collect the data. So in this case, we have about total 800 ticket power, right? And since we need to collect the feedback from the 5% of the audience, then if we collect feedback from every 20th person, then we can do 800 divided by 20, which is same as 40, right? So this is about 5% of the audience. So then we can say if we collect the data from every 20th person, then we are using a systematic sampling method to collect the feedback. Okay, then CIII, we need to state the sampling method this time, which should be used if the survey is to be representative of the number of the children and number of the adults in the audience. So in this case, you can see that there is a subsection, right? Or the non-overlapping groups, because we are using children and adults. So we have a non-overlapping groups or the subgroups. And however, this method does not mention whether selection is random within the subgroups. So we can say that this is a quota sampling method. Then question D, we have a box and whisker diagram. So means this question is based on the section 4.3, the box and whisker diagram of the topic 4. Okay, so here we have a Q1 value, right? Lines for the Q1, lines for Q2, and we have a lines for Q3. Okay, then DI, we need to estimate the number of the people who spend between the $3 and $25. So you can see from the graph, $3 is your Q1 and $25 is your upper boundary. So we know that Q1 is the 25% of the lower half, right? So means this is your 25%, and since Q2 marks the 50% of the data, Okay, then we know that this remaining part is also 25%. That means from the $3 to $25 is actually 75%. Okay, so to estimate the number of the people who spend between $3 and $25, we simply just have to do 36,000 times 0.75, and this will give us the value of the 27,000. Okay, then question DII, half of the audience spent less than $7. Estimate the value of the A. Okay, half of the audience, right? So we are referring to half, which is the Q2, right? So we say $7. A is equal to 7. So question E. So this is actually from the averages and dispersion section of the topic 4. So it goes like this. This year, the company will again give 60 performances and expects to sell 18 additional tickets for each performance. So we need to calculate the mean number of the tickets the company expects to sell this year for each performance, right? So we first, there's two methods to solve this question. So we can first first we can use the constant changes method to calculate the new mean value. Then to do that, we first have to calculate the original mean value. Okay. From the question, we know that there are total 36,000 tickets over 60 performance. So the original mean is 36,000 times 60, which is equal to 600. Okay, and we are adding 18 additional tickets for each performance. So using the constant changes method, if we are adding exactly same number point to each each category or each class, then the new mean is same as the old mean, plus then the new mean is same as the old mean value plus this increased amount for each class, so which is 18. So we do 600 plus 18, which is same as 618, or we can also use like old method, means we know that there's already 36,000 tickets, right? And then we are adding 18 per each performance for 60 performance. So we can do 18 times 60. However, still there are 60 performance, so we do divide by this whole thing by 60. Then we'll get 618. So this is also another way of calculating the mean for this question. Then EII, we need to state what effect, if any, this increase in ticket sales would have on the variance of the number of the tickets sold for each performance. So since we are adding exactly same number or the same number of the tickets for the each performance, we are not changing anything, right? So there will be no changes with the variance. So we can say no effect on the variance.